Okay, so this is the video for chapter 9, and this is probably the last chapter for this course. And I'm using this PowerPoint for the presentation. You can also find the same PowerPoint on Moodle after upload the video, as well as all the related materials on Moodle. You should be able to get all the information from Moodle. In particular, you should be able to get the lecture notes on Moodle as well, and because I will refer the lecture notes even when I'm making this video. So you better have the PowerPoint and the lecture notes on your hand when you're watching this video, because otherwise you don't know what I'm talking about. Okay, so this is the video for chapter 9, and let's just start the video. And um, actually, um, as you know, this is the last chapter. There are not many questions left for this course, and I just picked two problems for discussion. And the first problem is called the matching marriage problem. So it's like you have a group of objects. You want to match up those objects. So how can you do that? Okay, so this is the matching problem. Um, and then the second one is the Chinese postman problem. So that problem, maybe you may be more familiar with it, because in fact this is the Eulerianization problem, but we are doing the problem for some more general graph. So before, we have seen problems involving Eulerianization, but in those cases we don't have that many odd vertexes. Okay, so but here, in fact, you can do it for any other graph, but the problem will become much more complicated. So that is the Chinese postman problem. Okay. Now, let's just begin with this matching marriage problem. So imagine that. Okay, so you are the agent of a dating company. Okay, so you just open. You're not open to the company, but you were hired by the dating company. So what is your job duty? You have to, for example, organizing some speed dating. Okay, between some ladies and gentlemen. Okay, so that means you have a group of people. Just make it simple. You have 5 men and 4 ladies. Okay, so I use the the small alphabet letter for the men, and I use the capital letter for the ladies. So I have 5 men and 4 ladies. So I want to match them up. Okay, but as you know, those ladies and men, in fact, they have their preference. Okay, for example, some men they like tall girls, while some ladies they like some guys with well with some other characteristic, like maybe they like some men with higher academic qualifications, something like that. I don't know actually, but they have different criteria. Okay, so that's why when you are doing the matching, okay, so um, you have to also consider the qualifications and some expectations from the ladies, whatever. Okay, so this is the summary for the constraints. Okay, so remember, capital letter A, B, C, D are the ladies. Okay, so for example, lady A may be interested in meeting gentlemen's ABC. Okay, and then lady B may be interested in meeting um, the, 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 the gentleman BCE, etc. Okay, so we have the list of the constraints, and then when you're doing the matching, you have to match up with the constraints suggested by the ladies and the gentlemen. Okay, so otherwise otherwise they may have a fight. Okay, so that is not good because you're running a business. So now here is the question. So how should we match up the ladies and the gentlemen? So this is an obvious question. How can we match them up? Okay, and make the profit, not lose the money. So that's sort of a big question. Okay. Now, of course, you can randomly match up those ladies and gentlemen according to the constraints. Even though we have the constraints, in fact, we still have the freedom. You can do the matching as you like, but because we want to apply mathematics, so mathematics teach us some efficient method, okay, in solving problems. So not just for one particular problem, okay, we want to apply the same method to some other related problem. So this is one of the reason why we have mathematics. Okay, so it's not just for solving one problem only, but we want to apply it to as many problems as possible. Okay, and in an efficient way. Okay, so we want to save our time. So now one suggested method to solve the problem is to use graph theory. Okay, so we can draw a graph, okay, to illustrate the relation. So of course you can refer to the notes. So let me just go back to the notes. So here is the notes. Now exactly the same criteria, okay, the same constraints, and then I use this graph, okay, in showing their relation. So you see there are some vertexes. Of course, those vertexes are representing the people. Okay, so capital letter A for the ladies, small letter a for the men. Okay, so and we have edges. Okay, because it's a graph, so we must have some edges, and the edges actually are those interests. Okay, for example, here you see A may be interested in meeting small letter ABC. So this 3, because this lady, she is interested in these 3 men, so that's why we just use some edge to connect them. Okay, so that means if one lady is interested in the other man, then we use an edge to connect the 2 corresponding vertex. Okay, so that's the meaning for the edges in my graph. Okay, and let's see, where am I? Okay, so now what do you want to do? Well, we have the graph, okay, and we want to do what? Remember, we want to find the matchings, okay, matchings between the men and the ladies. So in fact, we just have to select, okay, some edges, okay, to pair up the man and women with the restriction. This restriction is important, with the restriction that each vertex can have one or none of its edges selected. Why? Because you don't want to see any fight, right? so if in order to avoid those competition, okay, so you better put that restriction in selecting those pair. Okay, so that means you won't. Okay, so when you pick the pair, okay, you won't do like you pick AA, okay, a capital letter A to small letter A, and at the same time you also pick big letter A to small letter B. Okay, then there will be a fight. Okay, because both men may interested to this lady. Okay, so we don't want to see that, so that's why we just avoid it. Okay. So okay, let me just go back to the full screen mode. Okay. Okay, so this is the first restriction, and the second thing we want to do is to maximize the number of selected edges. Okay, because as remember, we want to find the matchings. Okay, we don't want to just match up one pair. Okay, this is not other purpose. We just, because we are making a business. Okay, so we want to make as many matchings as possible. Okay, and at the same time, of course, you have to avoid those potential fights. Okay, so you want to find as many pairs of matching as possible, and and in order to get money. Okay, so this is the two goals, okay, when you're doing this matching problem. And I also gave you one example. So for example, you can pick this. Okay, that's possible because they are linked up by one edge. Okay, so okay, so okay, let me maybe go back a little bit to the to this graph. Okay, so we pick this. Okay, and then you can you can do similar stuff like, okay, so you once you pick A, B, okay, then you will avoid any other pairs linked up to A, capital letter A and small letter B. So maybe the next pair will be a big letter B and small letter C, okay, and so on. Okay, so actually they are sort of depending, okay, depending on one another, because if you choose one pair, then you have to avoid those other potential pair which link up to those vertex. Okay, so you're not that free, okay, to choose those pair, otherwise you might have a fight. So how can you make the process as systematic as possible? So if you randomly, okay, as I said, you will randomly choose the pairs, okay, you might have a situation that okay, some vertex are already already taken, so you might have the possibility that, okay, I choose some pairs which have some common vertex, okay, and that's not good, right? So what should be a good method? And in particular, how can we get more? Okay, so actually there's a very good funny method, okay, which can not just give you one pair, okay, but in fact give you 1 plus 1 many pair. Okay, so give you one and another one pair. So this is a very interesting method. So let me show you. Okay, so for example, you've as we did in the last slide. Okay, we pick this pair, capital letter A to small letter B. Okay, we pick it, and then from the two ends we try to find some other edge which goes which go to some other vertex. So for example, from this big letter A, actually I can find another edge. Okay, if you go back to this, okay, so remember this is the one we pick, and then from that vertex A, I try to find another edge running out from big letter A. Okay, so for example, I can pick A to small letter A, but not going back to the small letter B. Okay, so that's it. On the other hand, from the small letter B, I can try. Okay, you can just try. Okay, that may or may not be possible. Okay, depending on the constraint. Okay, so from the small letter B, I try to find another edge which starting from B to some other vertex, but not vertex A. Okay, so for example, here you can go from small letter B to big letter B. Okay, then you pick another pair. You just pick another pair. So in other words, now from the original pair, big letter A to small letter B, you now find two more. I should say find two other pairs. Okay, namely big letter A to small letter A and big letter B to small letter B. Okay, so one give you two. Okay, this is the idea. Well, in fact, okay, even though we all know, okay, how it works, okay, one pair give me two, still it's not that easy to write down all the pairs or make a good record on what you're picking. Okay, so that's why we try to use numbers. Okay, so this is another way to say, well, I want to find a better bookkeeping method, okay, in keeping my steps. Okay, so here this is the suggested method. So we use a table. Okay, so you can find these two tables from the notes. So now the first table tells you what? tells you actually the presence of the edges. Okay, so if there's an edge between the two vertex, I put the number 1. Okay, otherwise if there's no edge, then I put 0. So here, as you can see, for example, for the big letter A, so big letter A to small letter A, big letter A to small letter B, big letter A to small letter C. So we have 3 edges, so that's why we put 1 1 1 on the corresponding entries. Okay, and because you couldn't find any edge between big letter A and small letter D and big letter A to small letter E, so that's why you put 0. Okay, etc. So by doing that, you get a table which only involves the numbers 1 and 0. Okay, so as I said, 1 denotes the presence of edge between the two vertex, while 0 denotes the absence of the edge. Okay, so we have this table, and now that's the okay. So now we have the table, and let's see. Now, in getting, to select the edge, we simply circle the corresponding entries from the table. Okay, so that means when you're picking those edge, you just circle it. Okay, now for example, if you want to pick this 2 edge, then you just put a circle on those edge, and remember you better put the circle on the number 1. Okay, because 1 means there's an edge, otherwise there's no edge for the pair. Okay, so that means you won't put 0 on 0. No. You won't put the circle on the 0. Okay, what I'm saying. Okay, so now that's the way to do it. Now, and how can we represent the method we just discussed before? How can we get 2 pairs from 1 pair? Okay, so this is the way we can do it using that table. So let me just go back to this table. Let me go back to the PowerPoint. Now, here you do what? Okay, you look for a chain in this form. Okay, so starting from 1, then you go to a circled 1, and then you go to some non-circled 1, and so on. So you have to do it in an alternating manner. Okay, so here this is exactly what you need. Okay, now how? Okay, how? What is that chain? Okay, so okay, from this table you couldn't see the arrows. Actually, there should be some arrows running between the uncircled ones to the circled ones, and then the other way. So for example, here, okay, so here you can do it like you start from this one, and then you go to this B. You go to that circled 1, and then you go down, okay, to that one, and then you go to the right to this circled 1, and then you go down, okay, and so on. So this is the chain, okay, the so-called chain we are looking for. Okay, and we have one important rules which we must follow is we can only, okay, so make sure that only one circled 1 in every row and column in the table, because what is the meaning? Okay, remember the circled ones are corresponding to those edge you just pick. In other words, you just pick that pair. Now, if you circle 2 ones on the same row, okay, what is the meaning? That means that, for example, you also circle this. That means this vertex, this lady, okay, this lady A will be connected to the small letter B as well as the small letter C, because you pick the 2 pair at the same time. Then again you will see a fight. Okay, so that's why you won't do it. Okay, so that's why you have to do it in an alternate manner, as well as you have to make sure that on each row or column you won't pick more than 1 edge. Okay, that means you won't see any you can only see one circle at once. Okay, so this is the chain, okay, we are looking for. Now, but that's not the end. Okay, in fact, the most interesting part is after you pick that chain, you flip it. Okay, you flip it. Then after the flipping, you will get what? For example, here the circled one become uncircled, the uncircled one becomes circle. Then by doing that, in fact, now you will get one extra pair because, for example, imagine that okay, so you only have uncircle to circle and then uncircle. Okay, just stop at this, and then if you do the flip, then you now after the flipping you get you will circle the first one as well as the last one. Okay, so the two ones will become the selected pairs. So instead of just one pair being picked, now you pick two. So that's why you get one extra pair, and that is true for any other chain. If you start with that pattern, then after the flipping you always get one extra pair. Okay, that is something very interesting, and that always give you one extra pair. Okay, now here I just recall the rules. Now make sure that there are only one circled one in every column in the table. I explained it to you already. If you don't want to see any fights, then just follow that rule. Okay. Otherwise, you can try to pick two ones on the same row or on the same column. Okay. Rule number 2. Try to make the number of selected edges as close as this number. Okay, the minimum of, okay, what is the symbol for this? That is the number of the elements inside that set. Okay, what is X and Y? Okay, maybe you forget it. Actually, X and Y are the collections of the ladies and the men respectively. Okay, so capital letter X give you the set of ladies. So inside that set, we have 4 ladies. So that's why the number of elements inside X is 4, and the number of elements inside Y, of course, you just count the number of men, that is 5. So those are the numbers of the elements inside the corresponding sets. So these two numbers, okay, you pick the minimum number. Okay, then that is the maximum possible pairs that you can pick. Right? Now, go back to this example again. So you have 4 ladies and 5 men, right? So no matter how hard you try, right? No matter how hard you try, the maximum pairs that you can do is just 4 pairs because you only have 4 ladies, right? So one man will have no lady because we only have 4 ladies. Okay, so the maximum pair that we can match up is just 4. Okay, so that's why rule number 2 tells you that you try to make the number of selected edges as close as this number, the minimum of these two numbers, okay, which correspond to the number of elements inside those sets. Okay, and of course, actually, rule number 3 is just an explanation why we have to do rule number 2 is because actually the number of selected edges is always less than or equal to the minimum of these two numbers. So if you can get it as close as that number, then you're done. Okay, of course the best is you get equality. Okay, so if you can make the number of selected edges exactly equal to the minimum of the number of number of elements inside X and the number of elements inside Y, then you're done. Okay, because you just do the best already. Okay, so here if you go back to this example, actually we did it because the minimum of 5 and 4 is 4. So if we can pick 4 edges, okay, 4 edges in the problem, then you're done. Okay, so you can try. Okay, you can try to see if it is possible or not. Okay, it's very easy. For that example, you can easily pick 4 pairs. Okay, using that flipping method. Okay, So yeah, so let me just go back to this PowerPoint. Now you may wonder, okay, again, why why do we have to use this method, especially this for that example, because that example is so easy. Okay, you can just solve it without any difficulty, without any table, without any chain or whatever. Why do we have to make that so complicated? Well, again, the method is very. I mean, the reason the reason are the following. Okay, so first, this method is easy for computer to learn and execute. Okay, this is the most important thing. We know we are human. Okay, we are smart, but the computer sometimes is not that smart. Okay, and if we can make the method as easy as possible, okay, so the computer can easily execute it, then it will save our time. Okay, we know the problem is easy. We know the problem is not complicated, but this is just an example. Okay, what about if you have a group of men which if you have a group of men of number of say 1,000, okay, and if you have let's say 2,000 ladies, then when you do the matchings, it's not that easy. Okay, especially you will make mistake. Okay, well, but on the other hand, if you can transform everything to just numbers and then put it in a table, then I would say the possibility to make that mistake is not that high. Okay, and especially if you ask the computer to solve it using that, finding chain and then do the flipping, you can always guarantee that, okay, you will get a pretty nice number of pairs, okay, from a table. Okay, so this is one reason why we want to use that method, because we want the computer to do that. Okay, we don't want ourselves to do it. Okay, we have some other task. Okay, but not something too tedious. If it's too tedious, ask the computer to do it. Okay, that's the first method, and the second one is it can always give us one more pair. Okay, because as I said, this flipping method always give you one extra pair. Okay, in fact, you can sort of repeat the step. Okay, if you think, okay, I'm not doing the best, well, why don't I just keep flipping? Okay, now, well, of course, if you want to repeat the step, then you have to extend the chain. Okay, for example, in the first step, you only pick. Okay, so let me just do it quickly. So for example, in the first step, you only do it up to here. Okay, then you do the flipping, then you circle this to ends. Okay, then you cannot just flip it again, because otherwise you go back to the original selection. So instead, after you do the flipping, you extend the small chain, okay, to a longer one. Then once you extend it, then you can do the flipping again, then you get one extra pair. Okay, of course it looks silly, okay, I mean to human, but for the computer, if you can have a good way to teach it, or to let it execute, then wow, that's a very good method. Okay, and it save your time. So this is the reason why we have to use this method to solve the problem. Okay, in particular, it can help us to maximize the number of pairs. Okay, so so this is the matching problem. Okay, so for the second part, I will talk about the Chinese postman problem, but that's the end for this part of video.